What is up, guys? Welcome to ONeill Code. Today we're going to go through a step-by-step walkthrough on how MergeSort works. We can begin by looking at this array of numbers. It has the value of 0 through 6 in it in random order, but we want it to be in sorted ascending order. The way MergeSort works is by breaking down the array into halves until we get a single node. Once we break it down to a single node, we put it back together in an ordered state. So let's look at this chunk of code. This is the first method that we will be using to do the recursion of splitting and ordering the array. To start MergeSort, we will input the first index of the array and the last index of the array. So in this example, it will be 0 and 6. Then we look at the base case, which checks if low is less than high. Since 0 is low and 6 is high, we move on. This statement will stop once low and high are equal, which means we were able to get a single node. The next statement is finding the middle of the range between the low and high. So doing the math, 0 plus 6 is 6, minus 0 is 6, then we divide that by 2 and we get 3. So we set middle to 3. Now we start the recursion with the call to MergeSort. We represent the left split by inputting the low and middle values into the method. The next MergeSort call, we will input middle plus 1 and high, which will represent splitting the right side of the array. Lastly, we will call a method called merge, which will actually do the merging and sorting for us. But since we were going through it for the first time, we will input 0 and 3 for the first MergeSort call, and now focus on that part of the array. So we'll be looking at 4061. And remember, we're not actually creating a new array, we're just focusing on a different part of the array. We then start MergeSort over with a low of 0 and a high of 3. We move past the base case and do the logic to get the middle. 3 divided by 2 is 1.5, but you need to round down, so the middle will end up being 1. We now call MergeSort with the input 0 and 1 and focus on the location 0 and 1. We move past the base case and get 0 for the middle value. We again call MergeSort with a 0 as a low and 0 as a high. Since both low and high are 0, this means we're focusing on a single node, which was our goal. We're going to go through MergeSort this time and fail the base case because the low is 0 and the high is 0. Low is not less than high. We will exit MergeSort and bring us back to the MergeSort with a low of 0 and a high of 1. Since we exit the left MergeSort call, we now move on to the right MergeSort call. We input the low, which will be middle plus 1, so 1, and then a high of 1. This will do the same we just did, and we'll get a single node. Since this will fail the base case, we exit the right MergeSort call and move on to the merge call. We will input a low of 0, a middle of 0, and a high of 1. The code for the merge call will look like this. We will input low, middle, and high, which will correspond to the position of the section of the array we are focusing on. We will create a helper array that will span the low and high value of the original array. Since we are looking at 0 and 1, we will have a helper array that replicates the original array for those positions. In the logic, the numbers array is the same as the array we are focusing on. We create the values I, j, and k. I and k will be set to low, while j will be set to middle plus 1. You will see how these are used in a second. We come to a while loop to check if I is less than or equal to middle, and if j is less than or equal to high. Once we enter the while, we check if the helper position I is less than or equal to the helper position j. Since helper position I is equal to 4, and position j is equal to 0, we go into the else. We set the numbers array position k to the helper position j. Then we increment j. All we did here was look to see if 4 is less than 0, since those are the two values in the area we are focusing on. Since 4 is greater than 0, we set the first position on the array we are focusing on to 0. So now our array would look like 0, 0 instead of 4, 0. But we are not done yet. We move down to where we increment k and do so. You will notice that we are only using k here on places where we were setting values in the original array. Now that we increment k, we are going to set the next position on the next go-round. So we start the while loop again, and we will fail because j is now greater than the high value, since we incremented it. It means we are looking outside the array we are focusing on. There is one more while which checks if I is less than or equal to middle. This will finish off the left side of the array that we have yet to copy over. Since k is 1, we are setting the original array position 1 to the helper array position 0. This holds the value 4, so we set it. Now the array we are focusing on is sorted 0, 4. This will finish the MergeSort call for 0, 1, so we move back up to the call with a low of 0 and a high of 3. Since we just finished the left side, we now do the right side. We input middle plus 1, which is 2, and then a high of 3. We are now focusing on the 6 and the 1. We go past the base case and start the left merge sort call. This will separate 6 and it will be a lone node. We then do the same for the right and we get 1 as a lone node. Now we do the merge on these two. We will switch the 6 and the 1 to be sorted and we get the result 1 and 6. Since we completed that merge sort call for the low of 2 and the high of 3, we move back up to the merge sort call with a low of 0 and a high of 3. We are going to call merge sort on this section of the array, and you have to remember that this is now 0, 4, 1, 6 because we sorted the subarrays already. When we merge, we will get 0, 1, 4, 6, which is an ordered state. We exit that merge sort call, and this brings us back to our original merge sort call. Since we just completed the left side of the array, we now need to complete the right. I'm going to go through this side on a higher level as it's the same thing we just did for the left. So we call merge sort for middle plus 1, which gives us 4, and then a high of 6. This gives us the array 5, 2, and 3. We follow merge sort call until we get a 5 and 2 as single nodes. Once we do, we merge them together as an ordered state, which gives us 2, 5. Now we need to do the right side. This right side only has one node, which is 3, so we already have it singled out. We move back up to the first right side call and we merge them. This will give us the result 2, 3, and 5. Now we're finally back at our original merge sort call. But before we merge it, let's look at the array. Now it's 0, 1, 4, 6, 2, 3, 5. So now we call the merge and we end up getting 0, 1, 2, 3, 4, 5, 6. And there we go, we finally have a sorted array. Now this may have seemed like a long process, but this is actually better than most sorting algorithms. Its worst case complexity is big O of n log n. Many will mention quicksort as a better sorting algorithm, and in many cases this is true. But quicksort's worst case complexity is O of n squared, which is worse than MergeSort. Another thing quicksort has over MergeSort is that it has constant size. It does not require any extra arrays like MergeSort does in the merge portion of the logic. So there you have MergeSort. You learned the step-by-step process and you saw the Java code to get it done. If you liked the video, please give it a thumbs up. And if you want to see more from me, hit that subscribe button. Peace out.